Yeah, thanks. Good afternoon. Welcome to this talk. Today we'll talk about building an agentic framework in Samsara. I know agentic might mean many very different things to everyone, but for us it refers to using LLM to automate the workflows. So today we're going to talk about three topics. The first is what motivates us to adopt an agentic approach. Second, how we build one and with a focus on the knowledge-based chatbot. Lastly, how RAG helps us to build a flywheel driven by the customer feedback. Oh, speakers. My name's Yangyong, and I'm a machine learning engineer from Samsara AI team. Today I'm joined with Sven and Brian, are my colleagues. So let me firstly introduce about Samsara, what our mission is, and what do we do as a company. At Samsara, our goal is to help our customers to increase safety, efficiency, and sustainability of their physical operations. And I know you're now wondering, what do you mean by physical operations? So here, we're talking about a wide range of industries from transportation, public safety, oil and gas, to agriculture and others. So they're usually very labor-intensive and assets-heavy. So meaning many people are working on many different equipments and devices, which naturally involves a lot of the manual workflows. For instance, for companies in transportation, their daily routine jobs could be making sure the trucks can deliver goods from A to B safely and on time. To do that, you'll be working with truck drivers, mechanics, workers to load and unload cargo, dispatcher, fleet admin, fleet admin, and then you will have trucks, trailers, forklifts, and other assets to making sure the whole process can run smoothly. This indeed is a very complex chain of operations that we hope to help our customers optimize. So all of these industries, together with hundreds of millions of frontline workers, that's more than 40% of the world GDP. As you can imagine, any improvements or cost savings that we could do means a lot. Great. So how does Samsara achieve the goal? First off, we build a platform named Connected Operations Cloud to help our customers digitize and automate workflows. We start by collecting various operational data from the edge devices, such as Samsara's dashcam, sensors, vehicle gateways, and other IoT devices. And these data are transported to the cloud. This allows our customers to access and act on these data through our dashboard, and also gaining real-time operational insights. On top of these, we also provide integrated AI experience. For instance, our AI dashcam is able to detect different kinds of AI events, like the driver drowsiness you can see here, and the dangerous driver behaviors like rolling stop signs, tailgating, and the fleet admins can provide proper training and coaching accordingly. To summarize, we help our customers digitize their operational data, make it easily accessible, and providing actionable insights that can help them optimize their operations. But there are challenges to operate in large scale like we do. Our customers are from very different background. They're from different industries, and they could be speaking very different languages because they're from different regions. And the data they're trying to access can range from the device configurations to image, audio, videos, and inspection reports or other types of data. So as a result, there are many different kinds of customer needs, which leads to a lot of customer support tickets and costs, which can be quite costly. And we're not even talking about the customizations and the new feature requests. So not surprisingly, we saw LLM can help us to address at least part of the problems. But simple LLM integration doesn't really work. In our case, we have a lot of domain-specific knowledge and data, and oftentimes it's private. And they're being updated very frequently and still growing, which is now trillion level. And LLM doesn't really know. So RAG become our top choice. We started to build an agentic framework to test out different options and try to integrate the whole data that we have. But we do want to start simple. So with the help of the Llama Index, we are able to get a RAG knowledge-based chatbot up and running in just a few days. And right now, this chatbot has been already being used by a small group of customers, and they're happy with it. But that's not it, right? We're also trying to explore areas like image and video search, the real-time data queries, and other ways to use LM to connect to our customer data. Now, the big question is, how do we keep moving fast while making sure we're building the right products for our customer? Our answer is to build a flywheel. It's a flywheel driven by the customer feedback. In high level, there are a few key components here. First, we need to really build an extensive tracing capabilities that not only records whatever our customer is trying to do with our chatbots, but also collect the customer feedback for future triage. Then we can decide what's the next new feature we want to build, and then build them fast. And all of these new features are then being rolled out to your customer with proper eval and gating. And in this flywheel, you can see Ray plays a very critical role to enable us to do the automated eval and the feedback mining. And in the next 2 sessions, we will talk more about it. So next, hand over to Sven.
All right, thank you. I'm Sven, applied scientist. I've been working on the chatbot agent, and I want to talk about some of the challenges we ran into. Oh, did I press the wrong button? Are we off? Okay, maybe I can go on while AV figures this out. So building a chatbot agent is actually quite simple. You just put some prompt into ChatGPT, say you are a Samsara chatbot now, and it kind of works. And it's an impressive demo, and unfortunately, so unfortunately, it works kind of deceptively easily for a few demo use cases, but it doesn't really scale. So once you want to add more use cases, let's say you want your customers to fetch their personal data, you want the customers to query information about Samsara, you want to ask them about, okay, let's say I have a specific vehicle gateway, how do I connect this to my driver and so on. You run into all these problems that LLMs have, hallucinations and just taking data from the wrong database and so on. So how do we address this? And I want to give a simple example here, how you might start out with this chatbot. So you say, hey, I take just, let's say, Claude or GPT-4 plus my system prompt that says, if a customer asks for sales, here's the number you should give them. If a customer queries their data, here's a function you should call, and here's the JSON payload for it, and so on. And we would start out with this and say, oh, that's wonderful. These models are so powerful, we just tell them what to do, and it works. And as it turns out, it works for a quick demo. But then once you give it to actual customers, no, you run into these problems. So customer asks, where do I get a new cable? And the model kind of hallucinates something between the capabilities. Like, here's customer support, and here's the JSON you have to give them, which is, I'm not sure exactly why this happened, but it did happen. And it's kind of funny for us. But then our customers, they're not really tech nerds. They are like truck drivers, and they are fleet managers, and they might not find this as funny. So what do we do with this? And really, the way we approach this now is this, what we might call this agentic framework. We chunk this problem down. We say, whenever we say something like, if customer does X, follow this path of Y. If they do Y, then do Z, and so on. We turn that into sort of a graph, where we say, we take the decisions out into separate models. And these models don't have to be large language models, although of course they can be. They can be fine-tuned models where you just take an LLM and put some kind of fine-tuned head on top. But the point is you separate the decision from the actual prompts that don't follow up on these decisions. And this works really well for when your chatbot has many different capabilities, such as, okay, there's knowledge-based queries, and then there's data queries. And also when it's relatively easy to determine which direction should this go. Now, there's a downside as well, and that is ambiguity. And of course, now with going away from this simple prompt, you lose some of the flexibility of the chatbot to kind of infer between these domains. And we noticed at first when we launched this chatbot to actual customers, they wouldn't type in these nice questions that we could just classify, but they would just type in keywords. So what do we do if they type in fleet utilization? Okay, that's kind of a very common thing to ask for at Samsara. But it could mean that they want to ask the knowledge base. How do we compute that? What does it even mean in your context? They could ask for their data. Maybe they ask for where to find the report that lists that. And these are all pathways in the LLM, but then, okay, how do we choose? Do we just choose one and then hope that the luck of the draw gets it, and then maybe hope the customer asks again if they want to have something else? But the way we do this is through parallel execution. The idea is that when you type in a prompt, you don't necessarily know yet what this will be. Like, even you use an LLM that says, okay, whenever a customer is in this domain, do this, in that domain, do that, you will always have these ambiguous cases. So instead of just making a decision preemptively, we say, hey, let's just run all these agents in parallel. Let's always just query our knowledge base, see if there's something about utilization. And then afterwards, we can say, hey, okay, there was something in there. That's a pathway that made sense. And the same with data query handlers. There may be some data available, there might be no data available, but we don't really know unless we went into that expert model. Once you have that expert model output, you take the output and you can take something like a probability with it, so you know how confident you are, and then you have to run a synthesizer step. And that synthesizer, that may do different things. For example, if you say, okay, there's 2 pretty likely pathways, maybe I give a summary of each and then let the customer decide. They say, okay, which one did you mean? Or maybe I just say, okay, I just asked them the question. Or maybe none of the pathways matched, and then you have some kind of fallback answer. So then you can be really flexible, but you can be flexible at this step after knowing, okay, how much was there actually for each. And obviously the other advantage is you can really nicely parallelize this. You could run this on Ray, or you can have different experts on this that have very different compute requirements. So another interesting thing that came up was multilingual, because our customers come from all over the world. We have a lot in Europe now. We have some Mexican customers. And so it's nice if the chatbot speaks their language. And again, the deceptively dangerous part of LLMs is they kind of work. If you type into ChatGPT something in Spanish, it answers in Spanish. And same thing with our chatbot. We put it on, let's say, you put on Claude, and you put a prompt in between, and then you say, customer ask in Spanish. Usually it comes out in Spanish. But the key here is it's usually. And not always. And it's also not always the complete answer. So I have a German one here. I'm going to spare you the German here, but basically it's mixed between the languages. And this is actually quite common with LLMs, because LLMs, when your prompt and let's say the RAG nodes and the documents you pull in, they come from different languages, this attention to different parts of the prompt will cause the model to switch the language. So the key here is really that we have to be explicit about asking which language do we want. We don't just rely on LLMs to figure out what the customer probably wants. And the way we do that is by an early language detector. And that early detector, that really just runs on the initial prompt. What language could this be? It's just a classifier. Plus, we can take into account the user settings. So if it's not really clear because it's just a keyword like VG34, we would just fall back, let's say, to the user's language. And once this language is detected, we pass that into every single agent. For example, there's a knowledge base agent with the RAG database. That RAG database has localized articles, so we just pull these. There might be a data agent that pulls data, but that data is only in English. That's fine. We take the data, plus we added a helper prompt saying, okay, but the answer should be in Spanish. And that really helps to really solidify the answer in the correct language. Now, the last challenge I want to talk about is evaluation. And people always talk about eval, and yeah, we have to eval our models, and we have to run our flywheel, and we have to make sure that we're always raising the bar, improving the performance. But actually, a big problem for the chatbots is to really define what is good performance. And it can be quite deceiving, again, if you get a ChatGPT typical answer or some kind of llama answer that sounds nice. And even our customers, sometimes they say, oh, it's such a detailed answer. But then you go into it and realize, hey, but it didn't really help them with the question. Because the key here is when we build our chatbots for our customers, we have very, very Samsara-specific requirements for what a good answer should be. Here's an example, how to add an admin to the site. And there's kind of a Wikipedia-style answer to this. And that's kind of bad, because sure, if you want to learn about admins in general, like what is an admin, that might be useful. Maybe some customers like that. But we know actually there's some very specific requirements that come from our domain. And the experts on this domain are our customer support agents. They are the people who answer phone calls today, the people who help the customers, who help them by email, help them through support tickets. And we reach out to them, and we ask them, hey, people who ask this, like, what should the answer be? And we went through our own knowledge base, and we said, okay, here, look, these are the articles. What do we normally answer? And then we constructed this super detailed and highly specific for us data set that contains requirements. So we don't say, okay, this is a good answer, but we say a good answer to this question, how do I add an admin to the site in this example, is it should mention that there's 2 admin types. It should mention that this is the page you should go to for more information. It should mention that here, this is the path and the settings you should click through. And then these become our requirements, and we just judge our data and our outputs based on how many of these requirements are met. And the other advantage of this is, compared to, for example, having an LLM judge, this is a very stable measure. Because if you have a very concrete question, does it mention 2 admin types, yes or no? That's something we can answer pretty correctly with pretty high reliability. So you don't have this problem that your evaluator itself has noise in it and basically goes up and down depending on how often you run it and which model you use. And with that, I'm going to pass it on to our engineer for how we actually built this.
Cool. Thanks, everybody, for attending. I'm Brian Westphal, and I'm an infrastructure machine learning engineer on the team. And I'll be covering how we design the architecture and systems of our Flywheel to drive rapid development. So I'll be going over our iterative architecture, the tracing-centric stack, and some feedback and insights that we've had on developing a chat product. I hope that this is like practical information. If you're looking to build a chatbot, you can implement some of this. So let's talk about our iterative architecture. So the Flywheel is built on a system architecture that is designed for iterative development. So we maintain these tenets in our approach to designing our framework. So the first tenet is that we encourage experimentation by enabling rapid development. Being fast allows us to keep up with the latest developments in the AI space and innovate on new product solutions. So thanks to this approach, we're able to deploy first versions of products directly in our application in a matter of days. The second tenet is that we use a modular design with clear reusable components. It's important to define these architecture components up front to establish interface boundaries such as the intent classifier, agent API, data connectors, such that you can work on each independently. I know that this is pretty standard engineering practice, but at the rate that we want to deploy AI prototypes, makes this a first-class consideration when you're designing your software. So having a flexible system with common interfaces allows you to easily test new options and design for specific use cases. A good example of this modularity is in constructing an agent interface, just for starters. So we use a mix of in-house components for new agents and services, but we're also flexible to try out new third-party libraries like Llama Index, LangChain, et cetera, to quickly bootstrap solutions. We do this all the time. I'm sure everybody gets asked in here, hey, I heard about this new, chat LLM stuff. Can you go quickly develop it for me? This is like how we're building our software with this in mind. Another way defining system boundaries is important is in configuring models invoked and their respective parameters such as prompts, et cetera. For example, this allows us to easily pivot between using RAG-serve as compute for hosting agents to execute open source models, or we can quickly switch between running a vendor such as OpenAI. And as we all know, there's a new latest and greatest model every week to try out, so you want to be able to hot swap those. The third tenet here is that our rollouts are fully controllable for speed and flexibility. We target specific users in our application to trial new features and agent configurations to gather feedback while minimizing the risk to the main user base. And to facilitate this, our infrastructure is easily replicable and deployed with simple controls to conduct rollouts between the experimental and the main production environments. So in this diagram, over here on the right, I've shown just 2 environments, but in reality, we run over a dozen different environments from a single source code base, and we have fine-grained control over the features and configured parameters in them to try things out. So at Samsara, we have an operating principle we always want to sample the customer experience. So developers are encouraged to have their own environments where they're able to easily test out new things in the real end-to-end product. And on top of that, we have several dedicated deployments just for beta customers trying out new things so we can gather feedback, as well as just dedicated feature demos like image search, for example. And the last tenet here, number 4, is that all development prioritization is driven based on insights we receive from feedback throughout the app and measurement through our systems. So we treat measurement as a first-class consideration, and I'll speak about more how we handle this in the next slides. So tracing. Tracing is the backbone of our feedback loop. On the right here, you can see some example traces of the data we collect in our chatbot. This data includes the contents of our chats for analysis, as well as direct feedback like thumbs up, thumbs down, and free-form feedback like how are we doing? Like why didn't this chat help you? We also include the user context, which lets us like revisit the scenario which the user approached our chat. For example, like what page are they on? Like what are they looking at? What do they need help with? What's open on the page? There's a lot of like metadata contextual things you can add to your UX to help you kind of understand and sympathize more with your customers. And all of this plays a key role when you go back and you're debugging and trying to figure out what's going on, why didn't things perform as expected. In addition, this trace data in aggregate is also used for just prioritizing system improvements. For example, tracing, we're measuring latency throughout all of our agentic call chains. And it lets us know like when we need to optimize any of those flows, like if any of them are performing slow, et cetera. In addition to this, you also probably want to instrument tracing to track your spend with LLM vendors because it can rack up over time. And next, I'll talk about how we integrated this into our framework. So this is our tracing-centric stack. Tracing and measurement is really, as I mentioned, like the central part of our stack. So all agent components are integrated with callbacks to our trace and measurement systems to capture the results of each step, the latency, and any contextual metadata that we might need later for like debugging purposes. This provides us granular insights over the entire flow of the system, such as the user text query embedding step, data retrieval steps such as RAG, and internal LLM turns, of which if you have an agentic framework, you might have multiple going on, and they're not always present to the user, but you might want to go in and see what they were doing inside later. And as mentioned in the slides, the tool we use for this tracing is LangFuse, and this is really the central store of all our data, and we use this to export all the contents of the chats later for offline tasks such as analytics and evals, which I'll cover next. So let's dive into how we gather feedback. So the driver of our flywheel is the feedback that we receive. So we encourage users to provide feedback in many forms, such as tracking UI interactions and also nudging them for thumbs up, thumbs down, free-form type feedback. And we closely monitor these engagements to see whether they're going through the steps as intended, did things break, what are our conversion rates, et cetera, for the new features that we're hoping to see. However, when it comes to getting feedback on your product, nothing really beats kind of like the manual approach, honestly. It's really important to like step in and see like qualitatively, like after you gather these traces, like what's really going on. If I was doing this, if I retrace the steps, is this really solving the customer concern here? Like the old saying, do things that don't scale. If you talk to your users and just ask them in a Zoom interview, you'll learn a lot more about the qualitative response. But of course, you want to do things quantitatively as much as you can. So instrument all of the typical UI metrics here. And when it comes to processing this feedback, all the data points, as I mentioned, are collected into our data lake. So UX analytics, LangFuse data, and we have multiple RAG jobs that run on several RAG clusters to pull this data and perform different tasks. So you can do all kinds of things with LLMs nowadays, like summarization of feedback. What kind of things were people asking about? What were the failure modes? They can help you summarize these things so you can scale it up. So when you're developing AI systems quickly, there's also a really strong demand to run evals to test new approaches and to prevent regressions. So to cover this demand, we built an eval engine on top of RAG clusters. So yeah, RAG is really, we think, like the perfect tool to just outsource this kind of complexity of coordinating the distributed compute workloads that would normally be required. It's just really simple to spin up a new job. Hey, somebody wants to run an eval? Okay, boom, fire it off. So we have this instrumented with Dagster as our orchestration system, which spins up RAG clusters. And this is really, really important to help you just speed up your own iteration cycles, because the more feedback evals you run, the more confidence you have in making your changes. And we're also in the process of adding Ray-Tune to conduct parameter search to find the best configurations for our tasks. This goes beyond the typical hyperparameter search. In an agentic framework, this might include trying out different prompts, different combinations of models, different flows, and different versions of data, just to name a few. So I want to talk about some of the insights that we've had developing a chat product. So if you are developing your own, hopefully you can learn from this. So we found some pretty common themes that influenced our feature building decisions. So the first thing is why are customers using a chatbot? Why do they find it so helpful? So we're developing a software as a service product, and often, these tools take some training to learn. And we found that customers are often just asking, where the heck is the page that does this? Or can you just quickly get me the data for this? So in Samsara's apps, we found that this could just be something like, okay, where's this vehicle? Who's driving it, et cetera. Having these really quick modes of hey, let me just talk to my data are really important. So these are some of the features we're thinking about building. When it came to unexpected findings, we were pretty surprised to learn that customers were happy with long-winded answers that provided a lot of detail. Even though initially we thought, oh no, our key metrics have to be that our latency is under a certain amount. No, customers actually liked when they got the info that they needed, which plays into my next bullet point. The users were unhappy with the chat when it was missing any of these key details. So it's important to tune your RAG performance and also handle those ambiguous inputs like Sven mentioned, which is those one-word searches, those little keywords like driver. Okay, what do you want me to do about that? It's important to resolve these with little refinement follow-ups in your UI, hey, you asked about this driver, what about him? Do you want to know how many hours he has left, et cetera? It'll help you, direct the user to get on the right path. And lastly, I just want to mention to think about your railguards up front. And we found that the best QA users for these kinds of tests were our internal coworkers, actually. So when we first built the chatbot, we all just kind of went at it and had an internal dog fooding session. I really encourage you to try to break your product because your users will inevitably test these in the wildest ways. So you should be ready. Nobody really wants to end up on the front page of TechCrunch because your chatbot started handing out coupons to everybody that visited your site, right? Yeah. And yeah, that's a wrap. Thank you all for joining us. Keeping it on brand with the Flywheel. If you have any feedback for us as speakers, you can follow up with us at happy hour, et cetera. And on the QR code there, Samsara AI is growing. If you're interested in working on cool problems in the AI space, real world applications, we'd love to talk to you. Thank you.
Any questions?
Hey guys, thanks for the talk and for sharing so openly. I'm actually curious about on the cost side of things. When you guys started spinning up the agents and agentic workflows, what was the impact in terms of cost of inference? Once you started to deploy this at scale.
So we're in experimental mode right now, but we find that actually the costs were remarkably reasonable. We're using mostly vendors too. So yeah.
Okay.
Does that answer your question? Kind of?
Yeah.
Yeah.
Okay.
Okay.
Thank you.
Yeah.
Future, can probably get cheaper. So
Yeah. It's a good curve to
Great
do.
session. So one of the questions on the development side of things, Flo. I saw you had an experimental user in one of the slides.
Yeah.
And you had the real user. So, like you said, there are new models, new versions of the models.
Yeah.
That's one part of it. But then before even you reach to the model, you have, let's say, a RAG system in place where you have some chunking strategy, re-ranking strategy, and all those sort of things, right? So a lot of combinations possible to test out what is a good response finally coming out of this chatbot, right? So for that experimental user, how quickly can you test those different combinations to frame up an evaluation strategy that this model version with this chunking strategy plus this stuff is good for my chatbot. So if you could elaborate a bit.
Okay.
Yes, I think the key is to create a golden data set. I think many ones like talking about that. So you have to firstly sample the customers like tracing. So we have we have very complete tracing mechanisms. We collect all the histories, and then we want to curate a very good golden data set so that you can just test out through that data set. I think that's the key way, because then you can.
Is your evaluation, sorry, follow up, is your evaluation stage wise or is it final output dependent?
It's like the eval, it's evals that we run, and then we just try out different parameters. It's like just the parameter search.
I'd like to add to that, actually. Since I mentioned all these sub-agents, we actually started with that, where we say, okay, we can also eval, for example, the RAG retriever. And when we built this data set, we actually built a little bit more fine-grained, that it can cover these subcomponents. And that's really nice about having the components, because we can work on them independently. We can switch out our retriever to add some kind of, add some context to the embeddings and so on, and then run that one. But like you mentioned, nothing really beats, obviously, the end-to-end, because sometimes you improve your retriever, but you actually get worse on the final result, because you get, let's say, more irrelevant articles there.
Yeah, the problem with the end result is you don't know then where in this, if they have 10 stages and to come to that end, you don't know where to
Yeah, I think the answer is both.
Yeah, thank you.
Should we? All right, I think that's it. Feel free to meet us, happy hour, or on the stage here. See you around.